Okay, I think it would be good to start now. Welcome back. Tonight, questions via Slido as before. Seems to mostly be working. I'm noticing that the numbers of people in the room now are dropping off, which is kind of what I expected, and I'd be interested in feedback. One problem with this subject is that the timetable is spread all over the place. So most of you who are here, I'm guessing, are probably have a lab either immediately before or immediately after this lecture session. Because a lot of, and maybe several of you maybe don't, because there's a lot of people that have labs sort of on Wednesday, Thursday, Friday this week. That's just the way it worked out. I have no control whatsoever over the timetabling. So I have been putting a lot more online lectures and so on this semester, as have a lot of UTS staff. And I'd be curious about how useful that is. Last week and this week I'm recording from the screen, and so I can put the whole thing on YouTube sometime tomorrow, so people that aren't here can still watch the lecture. But personally, I'm doubtful whether 60 minutes, like a one uninterrupted 60-minute recording, is actually very useful for people. But I'd be interested in what you guys think and how many of you are actually watching the lectures online, how useful that is. Would you like less of it? Would you prefer more of it so that you can not come to this class but only go to the labs and things like that? So if you've got any comments like that, you can put them into Slido. Is one way you could quickly give me feedback, like right now, or post to UTS online, or even just email me directly if that's what you prefer. But I really would be, and also you can give feedback. That's a nice segue. You can give me feedback through the early feedback survey, which is, I believe, open right now. There's a YouTube video there that I don't think I will actually play, from the Vice Chancellor asking you to please give us feedback. Obviously, you give us feedback at the end of semester as well, and that's really useful, and we take that into account, but it's not particularly useful for you people if you give us feedback at the end and then we go, that's what was sucking about the subject. Well, we can change it for next time, but it doesn't help you very much. So if there's, it'd be very useful to give us feedback, good and bad, like right now. So, and that would also be a good spot to give me feedback on the video lectures and how useful or not they are. Okay, let's brave Slido very quickly. Oh dear, okay. Okay, so how are we supposed to come up with 4 different scenarios for how people will interact with our work? Even 2 seems ambitious given our brief. I'm going to talk about scenarios and personas tonight. Pretty much the last thing I'll talk about. So maybe, I'm hoping that will become clearer. The answer to that question might become clearer after that. So let's hold off on that one for now. Could our assignment have more visual interaction than audio interaction, and vice versa? No, it doesn't need to be 50. So the audio and visual interaction does not need to be 50-50. It can be, audio could be prioritized over visual or the other way around, but we want both to be substantial. So it will not be enough to have a predominantly visual game with a few beeps in the background will not be enough. Yeah, we really want audio and visual to be substantial. Do we get emails? Oh, yeah. Okay, thank you for the feedback about lectures. Okay, I'll come back and check that throughout the night. So my interactive doodad of the week is the React table. And there's a short video of the React table here, so let me play that.
React table is a tangible physical segment based on a table. The React table started as a project 2 years ago, and unlike many projects which involve a lot of technology, it started from a concept and not from a technology. So first, we knew what we wanted to build, and then we discovered how to build it.
So you get the idea, I hope, from seeing this tabletop interface. Each one of these physical objects here either kind of causes a sound to be produced or modifies the sound that the table is producing. And as you turn the objects, you can change the sounds. So there might be an object which, say, controls the volume of the sound. By turning the object around clockwise, the volume increases. By turning it anti-clockwise, it decreases. But you might have other objects that change other characteristics of the sound, maybe that apply some kind of filter that changes the tone of the audio being produced, maybe that changes the tempo of the beat, stuff like this. And as you move the objects closer to one another, they start to influence one another. So, so you kind of create this network of sound-producing objects on this tangible table interface. Kind of makes sense? Yeah. So that's React Table, quite a famous interactive music doodad. And Bjork, for example, has made use of the React Table in her performance, so she kind of was trying to popularize it. And I believe it is a product that you can actually buy. And I think you can even download kind of the software and play with it. They actually developed an interface, they developed some software to recognize markers on objects. So you can actually use that software to recognize physical objects in your project if you wanted to, for example. But I'm not suggesting that all of you will do exactly that. I'm just giving you sort of some ideas for inspiration more than anything else. Any questions about React Table? Or other stuff to do with the assignment? No. Okay. Okay, so getting into some processing stuff. You already know about the draw method, so maybe I'm not going to go that much into this because we talked about it last week. You should recall that the draw method runs every time processing redraws its window, so that usually happens 60 times a second, and that's how you animate things, cause things to move around the screen. What I will talk about is drawing with curves in processing. And you would know from last week that drawing lines is pretty easy. We talked about using the vertex commands to kind of position points on the screen and then connect them up with a line to kind of like create a virtual dot-to-dot drawing. And you practice that in the lab during the week, hopefully. So you'd be familiar with this code. And you would know that drawing with straight lines is pretty easy. But often you don't want to just draw with straight lines, and a dot-to-dot drawing which is drawn with lots of straight lines has a particular look about it that doesn't suit everything. So if you want to draw curves, well, if you do it the low-tech way, it's a bit more complicated. So you could actually kind of plot individual points on the screen in a curved shape, and you can do that one pixel at a time, either manually by figuring out, okay, well, if I've got a point here, I can put another point there, and if I want to make it curved, I can shift it down a bit. Or you could get a bit smarter and start applying some kind of formula, like, you know, the y coordinate is equal to the square of the x coordinate, which if you think about it would kind of give you a parabola shape. Or you might do something like the y coordinate is equal to x cubed, which would give you a kind of a more, I'm not sure what you call it. It's not, what's the word for a cube? It's that shape. So you could do that, and there's an example of some code here that does exactly that. No, I don't want to download. So I don't really want to go into this code in great depth. It's not super exciting. There's nothing really particularly new there. But what they're doing is drawing a shape on the screen, which is based on drawing shapes on the screen essentially based on the y coordinate is equal to the square of the x coordinate, or the y coordinate is equal to x cubed. And if you run this, you'll see this is the one based on the y equals x squared, and this is the one based on y equals x cubed. So you get two different kinds of curves there by using those different formulas. So that's one sort of low-tech way, sort of low-level way that you could put curves into your processing sketch. But it's a pretty clumsy way, and if you think about having to use lots of these curves in your sketch and figuring out where to put them on the screen exactly and what formulas to use, it's pretty, you can see it would take a lot of time and would not be very efficient from the programming point of view. So fortunately, there are better ways where processing does do all that maths under the hood, but you don't, as programmers, don't have to worry about it. So there's 5 functions to draw curves: Bezier, curve, Bezier vertex, curve vertex, and quadratic vertex. And we're going to be focusing on the last 3 in this session. The first 2 work pretty much exactly the same way. It's just that the syntax is a bit different. But in terms of the graphics they produce, it's the same. So the quadratic vertex method uses a quadratic equation, which means it's an equation based on x squared. Yeah, something squared is a quadratic equation. So those curves have a shape something like this. So they have a single bend in them, I suppose. You're always bending in one direction. Like if you imagine you're driving a car along this curve, you're always tending towards the right if you're driving in this way. The curve vertex methods and the Bezier vertex methods use cubic equations, that is y equals x cubed type equation, which produces a curve that's more like this. So that has an inflection point, which means it has a direction change. So again, if you imagine driving your bike along this curve, you first of all, you're kind of trending left, and then you get to a certain point, the inflection point, where you actually start to head to the right. So these curves have a direction change. So quadratic vertex doesn't have an inflection point, doesn't change direction. Curve vertex and Bezier vertex does change direction. So with quadratic vertex, if we take that one first, that's the one that gives you this kind of shape. The way you do it is you first put an initial anchor point. This is the first point on your line, the end point of the line that you're going to draw. Then you put a second anchor point, the end point of your line on the screen. So you give x and y coordinate for the beginning of the line, x and y coordinate for the end of the line, and then also a control point. And this is the point that the curve is going to kind of move towards. Yep. So let me run some code to show you an example of that. Okay, so here we have a curve. This is the beginning point. This is the end point. So they're both, this is the initial anchor point and the end anchor point. And this is our control point. And so as I move the control point around, you can see the curve. It's basically like it's attracted towards the control point. So I can change the amount of curve by just dragging the control point around. And if we look in the code, there's a bit of stuff there that just kind of gives us graphical user interface controls so that we can drag and drop things, we can drag the control point around. But the code is essentially very simple. We start off by giving our initial starting point for the line with the vertex command. Then the quadratic vertex function, we pass in the control point coordinates and the final endpoint of the line coordinates. And that's essentially all we have to do. The rest of the code is just drawing the GUI elements that we're using to manipulate the curve. Yep. In terms of actually drawing the curve, you just got about 2 or 3 lines of code. Begin shape, initial point, and then the quadratic vertex giving you the endpoint and the control point, and that's it. And then end shape to wrap it up. Make sense? Good. Let me do a quick Slido break, just for comedy reasons. Whoa. Okay. Where do I find these interactive doodads? I usually just Google for them. But yeah, over the years, I've accumulated a fair collection of links to interactive doodads to use in these lectures. But I'm sure one thing you guys should have been doing last week and will be doing this week is just trawling the web and finding all kinds of interesting and inspiring and weird and wonderful interactive doodads in the area of interactive sound and visual kind of instruments and or sonifications, visualizations of data. Can we use processing for Android in our project? Yeah, it's a good question. I haven't actually used that. I'm not sure how difficult it is. If you have to negotiate with your tutor, if you and I guess we're not opposed to it on principle. If you want to use processing for Android, or I'm pretty sure you can deploy processing on iPhone as well without too much trouble. But you need to show us that it's simple and that you're not going to get distracted by a whole lot of technical hurdles that are going to take your focus off designing interactive doodads and learning processing and pure data. Okay, moving on. Okay, so if you want to create more complex curvy forms, you can obviously create more than one quadratic vertex, so you can have more, curves going in lots of different directions. So if I have some code that shows you that. So here I've got very simple code that starts with plotting an initial anchor point. Then it plots a quadratic vertex over. It plots a control point over here, another endpoint there, and then a second quadratic vertex with a control point over here and the endpoint here. So we've combined two curves into one. And you can obviously do an arbitrary number if you want to make really squiggly, curvy shapes all over the screen. You can do that just by chaining these quadratic vertex calls one after another. And quadratic vertex form, there's a good example in the book that produces a whole bunch of... Oh, okay, this one just does one. So yeah, this one produces a nice curvy shape using similar code to what we did when we drew our polygon last week. This is using very similar code, but instead of just doing straight lines to connect the points, we're now putting kind of curvy lines between the points. So if you look at the code, you'll see pretty much it's the same. It's very much derived from last week's code, but using curves. And this one has a bit of randomness so that it plots the control points at different places. So there's a bit of randomness. It varies the number of points around the circle and also the position of the control points. So you get all kinds of interesting shapes. Each time you run it, you get a different one. Okay, so that's quadratic vertex. Bezier vertex uses these Bezier curves, which were originally developed, I think, in the 40s or 50s, maybe, by a guy called, I forget his full name, probably Francois or something, Bezier, who was actually an automobile designer. He was designing cars, and they were looking for like ways to kind of come up with nice curvy shapes for cars. And so they developed this equation as a way of kind of generating different curvy shapes to explore with car design. So with Bezier vertex, you're using sort of the cubic equation, so you get the inflection point. So when you do this, you set your initial anchor point with a call to vertex, and then you set 2 control points, which I'll show you in a sec what they kind of do. You set 2 control points rather than just 1, and the final end point of the curve, and then you end shape. And if I run an interactive example, you'll hopefully get a sense of how the Bezier vertex work. So here's a Bezier vertex. We've got our initial point in the middle of the screen, initial anchor point here. We've got the end of the line here, which I can drag around. And then we've got 2 control points. So you can see the curve, first of all, is sort of tending toward, initially is tending towards this control point. And then the second control point controls the second half of the curve, the second part of the curve. And so by moving these around, I can get all kinds of interesting curvy shapes. So if you want a curvy shape that changes direction, Bezier vertex could be a good fit. Again, I don't really need to look at the code because 90% of the code is actually drawing the user interface stuff, as I said. But if you look at it and chuck out all the user interface distraction, you'll see that essentially we're drawing an initial anchor point. We're then positioning our Bezier vertex and specifying 2 control points and the end point, and that's the actual bit of the code that actually draws the line. The rest of it is all just allowing us to interact and move those control points around dynamically. But yeah, the rest of the code's not overly complicated either, but it's a bit too complicated to go through in a lecture, I think. Well, there's not much benefit in it. Better for the labs.
I looked up Bezier's name, by the way.
Oh, yes?
It's Pierre.
Pierre, okay. Okay, well, that was my next guess, I suppose. But I shouldn't make assumptions like that.
It's French.
Yes. Jacques, yeah, okay. Any French people in the room? Okay. Apologies. I'm sorry. So there is a very wide range of different kinds of shapes you can generate using Bezier curves, and there's some example code in the book that hopefully a lot of you might have sort of had a look at that goes through and uses the random function to just create a whole lot of variations of plotting. Again, using the same code as last week, more or less doing a many-sided shape, but instead of connecting up our points of the many-sided shape with straight lines, doing it with Bezier curves instead, and varying the position of the control points. And as you can see, there's a massive sort of variety you can get there. So I guess the point to get is that with a very small amount of code, you can get a very large variation in quite interesting shapes. So if you were maybe linking this to some data or producing an interactive game or something like this, you can make use of this and save yourself an awful lot and produce quite impressive looking graphics with a relatively small amount of code. Okay, so one issue with the Bezier vertex command that you would have noticed is that the control points are not on the line. So when I go back, sorry, I'll just quickly run that example again. The interactive Bezier. So we get some quite cool lines, but these control points over here, oh my God. Focus. These control points are not on the line. So this control point is causing the curve to kind of bend in this direction, but it's not really obvious from just looking at this where this control point is. You wouldn't not necessarily be able to predict exactly where that line would go. So if you wanted to make sure that that line would go through a particular point on the screen, using a Bezier curve, it's a bit hard to do that. It's not very intuitive. So the curve vertex method gives you kind of the best of both worlds. It gives you nice Bezier style curves, but the control points are actually on the curvy line itself. So, and when I run the example, I think you'll probably see what I mean. And this whole Slido thing, I'm not sure now. Yeah, let me just run it first. So here we have a sketch that's drawn a nice curvy line, and it has a number of control points on the line. And you can see that by dragging these control points around, I can change the shape of the line. But it's probably a lot more intuitive way of controlling a curvy line than the Bezier method is, because the control points are actually on the line itself. So if I needed to make this line, if I needed to ensure that it passed through, the x and y coordinate 500, 450, if I plotted a control point at 500, 450, I could be sure that my curvy line would go through exactly that point, which could be very useful if I've got some kind of game going on or something like that. You need sometimes to have that level of control. How many control points can you have on a curved vertex? That's a very good question. I'd have to look it up. It may just be an arbitrary number. It may be like no limit. But okay, it's a good question. If anyone can Google it and put a response on Slido, that would be great. I'd have to look it up. But the thing to remember is it's a nice way of drawing curvy lines, and it gives you quite intuitive control. If you can't have like an arbitrary number, then you could certainly just chain several together to get the same result. And the other little parameter that you've got control of is this sort of curvature control here. So it changes the degree of curviness, I guess you might say, of each of the control points. So if you leave it at 0, you get kind of a curve like that, but you can mess around with it to get slightly different shaped curves. To change that parameter, you use the curve tightness method. So by changing the parameter you're passing to curve tightness, you get different shape of the curves as they go through each one of those control points. Okay, any other questions about curve vertex, Bezier vertex, those kinds of methods?
Do you think it's easier to create a GUI to edit curves, or easier to hard code it in? I guess it depends.
Yeah, I think you've answered your own question in a sense. Yeah, is it easier to like hard code the control points for your curve, or is it better to put in a user interface so people can drag the curve around themselves? And it completely depends on your application. what you're doing. What you might want to do is, say, map some data to a control point on the Bezier curve. So if you're getting data from the building about the temperature of a whole bunch of rooms, and you want to somehow plot that into a nice curvy graph or a curvy shape of some kind, you might take the temperature as they might set the x coordinate of your or your y coordinate of your control point on a curve vertex, for example. But you might want to give the user control over that to some degree as well. So just depending on what your app is, you would do different things. Any other questions? Okay. Okay, so this subject is kind of, it's kind of a design subject, but it's kind of a technology subject. So in the last few weeks, we've been focused on processing and very much getting our hands into coding stuff, figuring out how to plot things on the screen and how to make things a bit interactive. But we want to get a balance in the subject between learning the technical stuff and also thinking about design, because we're designing things for people, and just knowing about code isn't enough to do that. So if I've got a question for you, if you're designing some kind of interactive doodad for people to use, what can we do to learn about our potential users? So what are the things you could do to learn about potential users? Some of you might, if you're working in the industry, some of you might be doing this in the company you work for.
Maybe you could post a demo and get opinions and stuff from people.
Yep. So let me just create a slide with some learning about users. So you could post. You can post a demo and get feedback. That's one thing you could do to learn about users.
Do hallway usability testing, so just pull people in that you see and get them to try and use it.
Yep, you could grab a bunch of people like more or less at random, just to happen to be walking by and say, we've got this prototype app, come and use it. So yep, what else?
Construct fictional users.
Good answer. Construct fictional users, like we're going to be talking about with personas, for example. Yeah. So we could basically imagine who would be using our app. Absolutely. Yep. You could construct focus groups. So you have a particular idea for a particular kind of app you think, and you bring people in who you think can give you good ideas, and you ask them, about their experience, about what their interests are, about other things. If I could, yep. So any other ideas for how we can learn about our users?
We can conduct some consumer research, just maybe use like some existing data that would want us to needs of the users.
Yep, so consumer research where you find existing data somehow or other based on some group of users.
Other doodads.
Like other doodads?
Their research, yeah.
Oh, yes, yep. Draw on others' experiences with other apps. Yep. Any other suggestions for how we can learn about users?
Observation.
Yep. Observation. Look at people. If you're going to be writing apps that you think people are going to be using on public transport, for example, you might go and sit on buses and watch people using apps on the bus and see how they behave. Try and get a sense of what's going on there, just through observing. I'm going to come back to you, yeah, but is there any other?
Get a bunch of good friends who's honest enough to tell his feedback.
Yep.
Strangers always give positive feedback and not constructive ones.
Ask your friends. So ask your friends for feedback because strangers always give positive feedback. I don't know. I've had plenty of negative feedback from strangers as well as friends, but yeah.
Conduct user stories. Get user stories.
Get user stories. So where do they come from?
I don't know. I guess ask random people.
Oh, so you actually ask people for their experiences and their stories?
Just ask them what our users
Sorry, what was that? And I've lost track of what you said. Make up stories, yeah?
Well, yeah. Well, yeah, get user stories.
Oh yeah, get user stories from users. So like by asking people, tell us about how you might use app X.
What happens to you interested in?
Oh yeah, okay, yep, good.
Yeah, it's a bit to grab people and ask feedback, but in a more constructive way, where you do a usability testing, where you take all together, you make a user story, you ask the user to conduct whatever you want for the end goal, and then you look for responses. You see how many clicks the person did and how the person behaves, and you observe. Yeah.
Okay, yep. So,
It's called usability test.
so you do usability testing where you, assuming you have some app, or maybe you have, maybe you have an existing app from some other company that you think you could make a better version of. You get that, you stick it in front of a bunch of people and say, your task is to book movie tickets using this app, go for it, and then you watch them click on different things and get lost and sort of roll their eyes and get frustrated, and then you try and make your app address those issues. Yep. So yeah, detailed usability testing. Yep.
You could do a live stream of development, and people can start saying stuff about it while you're developing.
A live stream
So
of development.
You live stream your development of whatever you're doing.
Oh yeah, yeah.
People start making comments and stuff about it.
Okay, so basically you release your app or whatever it is as frequently as possible. You release your app as frequently as possible and get user feedback. Continue.
Like you literally live stream it.
Literally live stream it. Okay.
Like so it's live. People can see you developing live.
Okay, so they actually see you typing code.
Then they'll make comments to you, and then you'll see their comments live as well.
Okay, yeah, that's very fast feedback. Okay, so live streaming development. Okay, so there's lots of ideas there for how you go about finding out about users, focus groups, interviews, observing people, going out into the environment where they're actually going to be using your app and putting yourself in that situation and trying to experience what the users are experiencing, those kinds of things. So that's the kind of stuff we're not going to be doing a lot of in this subject, but I would encourage you to do it, especially early on when you're brainstorming ideas for the design of what you're going to build in this subject. So even though this subject will not focus on this stuff because we're focusing on more the techo stuff, I very strongly encourage you to think about ways you can get the benefits of this kind of stuff in your development as well. What we will be asking you to do, and like one way to get inside the minds of your potential users, and a kind of quick and easy way to do it, even if it's not as comprehensive as some of the other ways, is to write personas and scenarios. So many of you have probably come across this in other subjects, but a persona is basically a fictional but realistic, and I emphasize realistic, profile of someone who might use your system. So if you're building an election application to visualize data about the US election, you imagine, okay, who is a potential user that might use this application? And you basically, from your experience and from using your imagination, you construct a fictional persona, a fictional person, and you describe them in some level of detail. What do they like? What's their occupation? Do they have a job? What do they do? So it's a fictional but realistic profile. And I do emphasize again realistic, because I've read in previous years some pretty bizarre personas which are just are not realistic. So you really have to engage. It's like writing fiction. You have to, but it has to be plausible fiction. So that's a persona, the person, the imaginary person that's going to be using your system. And then the scenario is again a realistic story showing what happens when someone uses your system. So you're describing the situation that they're using your system in, what they're using your system to do. You're not focused on the technology, you're focused on the whole sort of scenario and the person's experience. So are they on a bus? Are they in a park? What kind of device are they using? A phone, like with a small screen, or are they using a massive computer like this one? what's the situation, and so the whole idea is to really get you thinking about what's the real world situation people are actually going to be using this in. Gets you away from your processing code and makes you think about, okay, wait a sec, when we put this in front of someone, what's their experience going to be like? So short of actually doing that, short of actually giving them the prototype and asking them for feedback, because at this stage it's a bit too early for that, this is a good way to get started. So there is, if you look on, there's a lynda.com video that you can check out that explains this in more depth, and I encourage you to check out that video. You can also read more about personas in this interaction design book, which is also available online through the UTS library. But here's an example of a persona that I kind of threw together this afternoon. I don't know, I can read it out to you. Hands up if you want me to read it to you. Okay, you guys win. Julie is a 26-year-old barista and part-time student working in a cafe in Newtown. She's due to finish her business degree at Sydney University at the end of this year. Presently, she's sharing an apartment in Marrickville with a fellow student, but she tends not to spend much time at home, preferring to spend the hours she's not working or studying with her girlfriend. Julie is very politically aware and is particularly concerned with issues relating to the environment. She has been supporting the Greens and is keen for the Australian government to increase its efforts to reduce global warming. So that's as much as I came up with to fit on this slide, but you could easily expand on that a couple more paragraphs. So it's still kind of a thumbnail sketch of a person, but a believable thumbnail sketch. So I'm not really unlikely to be describing someone who's an astronaut on the space station or anything sort of really wacky like that. It's a plausible scenario, a plausible persona, someone who's likely to be interested in whatever it is we're making. So any questions about persona before I go on? The concept is reasonably simple, but it is also easy to do it badly. Is there a maximum length? I think for the assignment, I'd just say it's like a page, maybe one page. I think I asked for both. That may be something I would have to check out. Let me quickly bring up the assignment, just make sure I haven't made an error. So yeah, invent and describe some typical users and how you imagine they might like to use your project. So I've kind of wrapped up I guess I haven't expressed it separately there, but I have said invent users and create a scenario. So maybe I should clarify that. So I do want a persona and a scenario. And here's a scenario, and I'll read it. Julie is sitting in the park near the cafe where she works, eating her lunch. It is 2:30 p.m. and while she's eating, she checks Facebook. She sees that one of her friends has shared a link to an interactive app which shows how average temperatures around the world have been changing over the past 100 years. Using her phone and headphones, Julie is able to perceive patterns in global temperatures and other weather features such as wind speeds, ocean temperatures and levels, etc. The screen size of her phone is small, so the amount of detailed information that Julie is able to meaningfully engage with is small. She's more intrigued by animations and accompanying sounds that help to convey the meaning of the data in ways she is better able to grasp than more traditional scientific visualizations such as graphs. So again, you're trying to imagine the actual real world, real life situation where someone is interacting with your app. Where are they? If they're in a park, then the way they're interacting with your app will probably be quite different than if they're sitting at home, at a large scale, at a large screen computer, for example. So hopefully that gives you a sense of what a persona and a scenario are and the kind of thing we're looking for in the assignment. Again, I stress they need to be plausible and realistic. So I guess a common mistake I see with scenarios, just to make it clear, is people will often say what an awesome experience using the app was. So they will say, oh yeah, Julie logs in and she uses the visualization and she suddenly realizes the answer to everything and how global warming can be addressed through using the application, and she's totally sold on it, and she donates $1 million to the company that made it. So it's just, yeah, a completely over the top and unrealistic situation. So we want to hear plausible descriptions of how people are interacting with your application. And we're interested in where these scenarios really highlight design challenges for you. That's the purpose of doing it in a way, is mostly for you to put yourself in the shoes of your users and get you out of thinking just about processing code. Okay, any questions about that before? Yes, we wrap up.
Does it have to be a product that we have to sell in the future? Can it be just something interesting idea or contemporary art?
Yes, it can be. Well, in the case of the app that you're developing for this subject, it doesn't have to be a product. It can be just an interesting app that makes people think about stuff. So yes, it could be an artwork, definitely. Yeah, and I'd encourage that actually. Yeah.
If it is an artwork, how are you supposed to have 4 different scenarios of how that's being used?
Okay, yeah, so that's a good question. So that's coming back to that, the question that was on Slido earlier. So yeah, you could, if you have an artwork, there could be easily 4 different scenarios. Maybe maybe one of the users is experiencing the app in a gallery. Maybe one of them's experiencing it on the bus, on the mobile phone.
The assignment says that it's supposed to be, they're all supposed to be in building. Why are they in the building 11 foyer?
Oh, okay. That's a relic from last year. I need to edit that as well. So that was the assignment last year. They were in building 11. In your case, that's not a constraint. But let's say you are designing an app to be shown in a gallery. Some people visit the gallery on their own, which is one kind of way to experience it. Other people might have like 3 screaming kids with them at the same time, and their experience will be, again, quite different. Depending on the background of the person, the persona. If a barista from Newtown who's interested in environmental issues might have completely different kind of perspective to someone who is, a lecturer at a university. It might be different from someone who's an oil rig worker, all those kinds of things. So you have a combination of different personas, different scenarios. And I think it's actually, if you sit down and work on it like in the lab, you'll quickly see that you can actually come up with quite different scenarios and different personas without too much trouble. But if you are struggling with it, definitely in the lab, you've got your tutor there for 2 hours. Ask them for feedback, show them drafts, and they'll be very happy to help you out. Or post UTS online is another option if the lab is not appropriate. Okay, any other questions? Okay, so hopefully we've kind of covered left brain, right brain tonight. We've gone into some processing code and looked at curves and how to manipulate those in your processing code. And we've also dipped into some ideas from design, from interaction design, in not a very deep way, but we've just looked at personas and scenarios as a way for you to help start thinking about and engaging with the world of your users. That's it. I will see you in the lab. Unless maybe I'll just do one last check of Slido. Why don't we have shoots about and with hardware like the Connect and stuff? Yeah, good question. We will. So Connect, I forget when we get to it. It might even be next week, or if not next week, the week after. And we have Connects in the labs, and you can borrow the Connects, and also Leap Motion for gestural detection. And I'm also trying to order some MIDI controller type things with lots of knobs and sliders on them that we can play with. So. Okay. Yeah, so how will the creativity of our assignment be assessed? Very good question. We reward originality and creativity, and if you're in any doubt, ask your tutor. So the whole idea of having these tutes where we're working on the assignment is you get frequent feedback. So if every week you show your tutor the assignment and the tutor says it's not really very original or creative, it's not very original or creative, and week after week they keep saying that, then you can be pretty sure at the final mark you're not going to get a good originality or creativity mark. So if you're in doubt, show them what your idea is and get feedback. But we are not looking, what we don't want, and we've had some groups sort of do in the past, which we want to discourage, is just like, okay, we implemented Pong in processing and we're done. And that is not enough. Okay, it's impressive. Okay, maybe you've learned how to code in processing, or most likely you've just downloaded the code from somewhere else. But you haven't really engaged with the problem creatively or originally, so that would not get you a good mark. So the short answer is show your tutor and get feedback, and then you will know whether you're on track. Any other questions? Shrek. God. Yeah, I have been on MasterChef actually. I do. It's just it's like this is my day job, and Okay. Okay, good. And we're done.
Are you going to do Slido next week?
Never again. Might try it on MasterChef though.